Chemistry is the study of the structure and reactivity of all matter. And of course, right from the start, this may seem a little bit intimidating or impossible, maybe even scary. I mean, how in one semester could you possibly know the structure and reactivity of all matter? That would include everything in your daily lives that you see and you feel, everything on the earth, everything in the universe. Well, we'll do this simply by noticing the properties of all different types of matter around us and putting things into groups that have common properties. You, of course, do this already. You see the pen in your hand, you see the carpet on the floor, maybe the chair you're sitting in, and you notice that they're all solid and kind of waxy, and they can melt if you heat them, and you call them plastic. So you've already categorized a large part of your world just by noticing the properties of things that are plastic. You might also notice in a classroom that the tray and the legs of the chair you're sitting on and maybe the clasp on your watch all have common properties as well. They're shiny, they're solid, and if you were to touch some electricity to them, they'd conduct electricity, and so you call them metal. Well, in this course, you will learn how to put substances into their most important groups for the study of all matter. Now, we will also be concerned with the scale in which we make observation. Generally, in chemistry, what we'll be concerned with are the macro scale, which means the scale that you can see. Anything you can see with your eyes is on the macro scale. I have an example here. I have something that is coming out of this little hose. It's natural gas. You can see it, okay? And well, you can't see it because it's invisible, but at least you can hear it and you know that it's coming out of here. It's also mixing with the air in the atmosphere, and I'll put on my safety glasses, and I can light it. I can heat it up with a match, and it will burn. So a property of this gas is that when it mixes with air, it'll burn, and when it does burn, it changes into something new. We can see that. If we put something over the top of this, I'll put something over the top of this here, and what you can see is that it's changing its shade a little bit because it's getting condensation of water coming from the burner here. Okay, so that's on the macro scale. The gas is called methane, though, and the reason it reacts the way it does is because it's got certain types of atoms in it. Now, when we start talking about atoms, and we'll talk about atoms and molecules together, what we're talking about are the smallest part of something, and the smallest part of things are called atoms and molecules, and they are very, very tiny. They are so small, they're something like 1/1,000,000th the size of, say, you or me. Okay, so on this micro scale where we use atoms, if we were to shrink ourselves down to 1/1,000,000th the size we are now, what we would see is we would see something like this. Little tiny particles all linked together. That's the gas. Little tiny particles linked together in the air. That's the oxygen. Okay. And when they react, and I'll show that with an arrow here, they rearrange, and I get little tiny particles put together into molecules of water, and I get little tiny particles put together into a molecule of carbon dioxide. So we always want to be observant of what's going on in the world we see. That's the macro scale. We want to be able to interpret that in terms of what the atoms and molecules are doing on the micro scale, and we also want to be able to represent the atoms symbolically. which we would do this way. This would be called the symbolic scale, and we'll use those throughout this course in chemistry.